Hello everyone, I Nikhil welcome you to Vigyan Bharat. In this video today I am going to discuss problem number 3 from TIFR GS 2021 entrance examination. So let's begin our discussion. We are given an expression of the form in terms of the product of these factors 1 minus 1 by k square, where this index k runs from 2 till n, that is we have an expression of the form 1 minus 1 by 2 square, 1 minus 1 by 3 square till 1 minus 1 by n square. And now we are interested to calculate the limit of this expression as this index n tends towards infinity. This is an MCQ type problem, so certainly there are 4 options given to us and out of them one is correct. Now, in order to solve such problems where we are having these factors, we are going to utilize a known function which is very useful, which we often use it, known as the logarithm function. I'm going to use this function to simplify this expression, and further I'm going to use the property of logarithm to calculate finally the value of this limit. Okay, so let's move ahead now. First I'm going to assume the given expression, I'll give it a name, so I call it an in terms of this product. And now if you take the logarithm on both the sides, how going to this expression going to look like? First I have just simplified this expression. Now take logarithm on both the sides. So if you're going to take the logarithm on both the sides, this expression will going to look like this. Let's try to understand how we are getting this expression. If you see this first summation here, I'm using the properties of logarithm. What it says, if I have an expression of this form, where of course these elements are coming from which domain, then I can split them like this. Further, if I have an expression of the form this is same as this. So I'm going to use these two properties again and again. So let's, here in this summation, how this is becoming sum, because if you're going to take the logarithm on these products, so I'm going to use this property, that is it will become the sum of the individual products with logarithm, so that's why it is summation. And here the constants varies from 2 till n. I have given it a name, call it r, so this summation r varies from 2 till n. Further you can simplify it using simply ln of, this will be a square minus b square, so it will be 1 minus 1 by r times 1 plus 1 by r. So again, if you're going to use the property of logarithm, it will be, because it is a product of two terms, this is one, this is another, so it will be the sum of the individual logarithm. Okay, let's move ahead now. Now the complicated expression looks quite simpler, which is I have written like this. Further you can split it if you want, if you don't want you can remain it like this. Basically the summation will split. And now here, if you see what I have done, I have further simplified this expression. I'm doing for one, similarly you can do for the another. If you take the LCM inside, it will be ln of r minus 1 by r, which is again we're going to use the property of logarithm, so it will become this. So that's why the first expression is simplified to this one. Similarly the second expression will be going to simplify to this one. Now you can collect the terms which are similar. So here if you see these two terms, this one and the last term are similar, so that's why there's a minus 2 here. Now you can again basically replace summation everywhere like this. It's quite easy now. And further you can now expand these summations individually and group these terms in a bracket. So what I have done here, you can see I have expanded these summations and I am writing the expanded form inside these bracket, and whatever I am cancelling is the terms which will going to cancel. If you see here, ln1 is 0, we know by its definition. If you see here, these all terms are with the negative sign ahead with a 2 coefficient. So if you're going to collect the like terms in the first 2 brackets and see which will going to cancel, so those terms which are going to cancel, I have just written it like that. And it's quite easy to know that this ln of n minus 1 will going to come before ln of n. So there is ln of n minus 1 here also in the last expansion. Okay, if you're going to simplify it, going to cancel the terms, then you will going to, the simplified expression is going to look like this. And in this again, you can again use the property of logarithm. Ln of n plus 1 minus ln of n will become ln of n plus 1 by n, and this minus ln of 2, logarithm of 2 will again 2 will come in down. So again you have to simply use the property of logarithm and you can easily reach to this term. On the left hand side, now I have logarithm of an, on the right hand side I have logarithm of n plus 1 by 2n. But initially I was interested to find the limit of an when this n approaches infinity. Remember, I have given that product kind of thing name an, so I am interested to find that value of that expression when n approaches infinity. But here I have logarithm, so you can take exponential on both the sides and simplify this. So an will become n plus 1 by 2n. an will become n plus 1 by 2n. Further you can simplify, and now if you're going to take the limits as n approaches infinity inside this expression, so this first is a constant sequence. So limit of, I'm simplifying it, how it is going to look like this using algebra of limits. Simply this will become this. This is a constant sequence, so it is going to converge to 1, and this will going to converge to 0. So that's why the answer is 1 by 2, and this is the correct option. I hope you find this video to be useful. If you have any doubts anywhere, you can drop me your comments in the comment box. And just a useful information before we conclude this video, that we have a Telegram group on which I post some problems and their interesting solutions very often, and there also we share some good important resources. Further, you can get the updates related to our content there at the earliest, and you can also put your problems if you have any doubts anywhere over there. We will try to resolve that solution. So thank you so much for watching. We'll be meeting ahead in another interesting video. Thank you so much.